Hello everyone. Today I'm going to be taking up one of the practice thinking assignments that I gave you in class. We're going to look at the town of Matopia question with the population growth. If you want to follow along, you probably should load up the graphing calculator that's available on my website. Remember also the commands that we go through in this practicing assignment are going to apply to the real thinking assignment that you're going to do in a few days. So in this question, we have this town that was founded in 1982. I guess for consistency, it should be 1982. They record the population every 5 years, and we're asked to answer a series of questions based on this data. The first question asks us to use the TI-83 to input this data and to determine an equation for 3 different models that might represent the growth of this town. So on my TI-83, if you press the Stat button and then hit Enter for edit, you can input this data. You can see I've already done it. One word of caution and a common error that comes up: if I have a value in my first list that doesn't have a corresponding value in my second list, I'm going to get an error on my calculator. So when your calculator does its work with these sets of data, it needs to look for ordered pairs. If I have a value with no corresponding pair, then my calculator is not going to accept that value as part of my list. Okay. So I put my values into the calculator. I want to graph this, so I'm going to press second function and then y equals. And this will help me make sure that my plot is on. I'm going to hit enter twice to turn my plot on. And I'm also going to zoom in on my stat. So I press zoom and then number 9 for zoom stat. And it zooms in nicely, creates a window setting that zooms in nicely around my sets of data. And you could do the same thing if you were just playing around with your window settings. But you can see on the window settings that I have here, I don't think I'd ever guess those as an appropriate window to zoom in on my statistics, which is why pressing zoom and number 9 is a nice way to get a good view of all your data points. So I need to do some regression on this data. I need to compare the r-squared values for each of my equations. So to get my r-squared values, I need to turn the diagnostics of the calculator on. So I'm going to press second function and then number 0 for the catalog and scroll down to the diagnostics. Diagnostic on, I'm going to hit enter twice. So now my diagnostic is on. To perform a regression, press the Stat button. And I'm going to scroll over to Calc. And then you can see I have 2 options for 1 variable statistics and 2 variable statistics. If you take data management, you're going to learn about these. And I have many different options for different types of regression on the graphing calculator. I have a linear regression, quadratic regression, cubic regression. I have an exponential regression. Number 9 is a logarithmic regression. So I'm going to pick one, and I'm going to start with a linear regression. So I hit enter to select linear regression. I hit enter again, and the calculator figures out my A value, which corresponds to my slope, my B value, which corresponds to my y-intercept, but more importantly for us, it calculates the r-squared value of this data. So you can see the r-squared value for the linear regression is 99.2. So I'll record that information so I can refer to it later, and I'm going to perform another regression. This This time I'll pick a quadratic regression. Again, I can see my three coefficients and my R-squared value. This one's a little bit better than the linear regression. This is 996 for the R-squared value. And one more time for my third regression. You do want to try and pick something that will make sense based on the scenario you're given in your thinking assignment. I think since we've been working with exponential and logarithmic functions, my next regression probably should be either an exponential or a logarithmic type regression. You've learned or you've seen in this class, and more importantly last year in grade 11, that population tends to grow exponentially, so I think it's a safe bet to do an exponential regression. And there we see our coefficients. So I have three different models, three different equations, three different R-squared values. If I was doing this on a thinking assignment and I wanted to record my equations, writing them this way, like I have, and I've cheated, I've taken a screenshot from my graphing calculator. Writing them this way, I'd probably dock you half a mark. I'd want to see something like equals 1005.925 times 1.016 to the power of x. Okay, so I'm specifying this, and I would also like to see my R-squared value. Probably a good idea to try and keep as many decimal places in your R-squared value as possible. And I'm saying that because our R-squared values for quadratic and exponential very, very close to each other. If I start rounding off, in fact, if I rounded off to 2 decimal places, all of these regression models would look perfect. So the second question says, based on the table of values and the corresponding information, which equation best represents the population growth of Mathtopia? Decoding this question, I'm asking you to compare R-squared values. So yes, all these values are very, very close, and they're very, very close to 1, but one of these values is better than any of the other ones, and that would be the R-squared value for the quadratic regression. So I would say something like the quadratic is best based on an R-squared value of 0.9967. Okay, it's slightly higher than the exponential regression. And this is where the thinking part of this assignment really comes into play. We would like to explain why the R-squared value might not illustrate the best possible model for the growth of the population in Mathtopia. So I would go back to my graphing calculator, and I would plot the equations for my exponential and quadratic regression. There's a quick way to do that without having to plug in all these decimal places. If I go to my stat button and select my quadratic regression again, rather than hitting enter, I'm going to press the second function button and number 1 for list 1, comma, second function number 2 for list 2, comma, the variable button, scroll over to y variables and press number 1 and number 1 again. So what this command is going to do is going to perform the regression on list 1 and list 2, and it's going to save that equation into y1. So if I look at my y equals functions, you can see now I've got an equation saved in there. And if I press graph, I can watch that equation get graphed, and it's going through all of those points. So I'll do the same thing for my exponential regression. So I press second function number 1, comma, second function number 2, comma, the variable button, scroll over to y variables, press number 1, and then I scroll down now to number 2 so I can save my equation in y2. So see, now I have 2 equations saved. There's my first equation. Calculator's graphing my second equation, but they're so close together that you can't see them. So let's zoom out a little bit. So there's my quadratic. There's my exponential. Now I can see that they're starting to pull apart from each other. Let's zoom out again. There's my quadratic. And here comes my exponential. So now I need to choose which model best represents the situation that was described. I think if we choose a quadratic model, what this implies is that the population used to be very high, and it decreased, and then it started to increase again, compared to the exponential function, which started at a low population, and then started to rise as time went on. So if I was answering this question on the assignment, I would probably draw a quick sketch of my graph, and then I would use my graph to explain why the quadratic model is not the best, based on some reasoning from the real world. So one final question. When the population reaches 2,000, a new water treatment plant needs to be built. 45 years after founding the town, power plant will need repairs. We want to know which happens first. Again, you're given the graphing calculator, so I do want you to use it. I'm zooming back in on my data. And let's zoom out just a little bit. To make this a little bit more clear, on the calculator, I'm going to clear my quadratic equation, since I know that's not the one I'm concerned with. So there's my exponential curve. I'm going to graph the line y equals 2,000. What I need to find is the intersection between those two curves. So to find that on the calculator, if I press second function and trace, number 5 lets me find the intersection. So I'll hit enter twice, and one more time. So the population will reach 2,000 at about 44 years. So already we know that they need a new water treatment plant first. Just to show you, I could figure out when or what the population will be after 45 years. So let's do second function, trace, and then there's this command value. If I plug in 45 years for x, this tells me that after 45 years, the population is about 2,031. So I need a treatment plant first. do on your thinking assignment to back this up and earn as much as you can on this question is a little bit more justification mathematically. You could draw your graph in, you could draw those points in, and show me exactly why and tell me exactly how you figured out these two things are happening. So just to list off some of the commands that you need to know for Monday. You need to be able to graph functions. You need to be able to enter data into L1 and L2. You need to know how to turn your stat plots on. You need to be able to perform regression and find the R-squared values. And I just showed you again how to find the intersection of two curves and how to find the value, the y value of a curve at a certain x value. Okay, if you can do these things, you're going to be in good shape for the TIPS assignment on Monday.